So I find myself in a position to describe yet another cloud implementation. It's called StratusLab. My name is Charles Loomis. My name is Cal, so most people call me Cal. I work for CNRS in France most of the time, and I'm also a partner with 6 Squared, which is a small SME based in Geneva. I'm going to say a little bit about that at the end as well. So StratusLab, what is it? It's infrastructure as a service cloud distribution. So I don't have to say what infrastructure as a service is here. It is an open source distribution. It has an Apache 2 license. It's really meant as a solid IaaS base for building PaaS or SaaS applications on top of it, or for direct use by some users who really want just to have VMs. Our focus is a bit different than things like CloudStack and OpenStack, which we're going for the high-end type of centers. We're really going for the smaller ones and medium-sized ones, and really want to give those people a way to very easily transform their own data centers into a cloud. That's basically our goal. So we really want it to be simple to install. So as much as possible, you can take the stuff, install it, and do it very quickly. Typically, someone who's experienced can do this in usually less than a half hour, usually much less than a half hour. We want it, on the user side, to be as simple to use as possible. We provide a command line interface for users, which they do need to install, but it basically is in Python, a very portable Python, which basically runs on any OS out there. And the other thing which is important for us, especially since we're aiming at the lower end, the smaller and medium-sized sites, is it needs to scale down as well as scale up. So it's very important that we be able to do a very small installation of things, which our smallest is 2 boxes by default. You can kludge things around and actually do it on a single box. So we really want to be able to go from there up to a fairly decent-sized, medium-sized site. The other thing which is really important for us as well is the way we see cloud technologies being adopted over the coming years, and in the past years as well, is that there's a lot of people out there who are really interested in cloud technologies, both on the application side, the user side, and the data center side. And of course, Amazon and everyone else, the big providers, would like us to all just jump whole scale into using big commercial providers for everything. There's some problems with that, is that users, administrators, and developers aren't really ready to do that huge whole-scale jump. And there really is a chasm between those two different models. I think we'll end up there at some point, but I don't think we're going to end up there all in one jump. And so on the user side, I mean, the questions really are getting used to cloud technologies. How do users really use virtual machines to get their work done? That's what they need to do at the end of the day. And a really more important question is, how do they structure their data, access their data, and all of that in a cloud environment? It's something they're not used to. It's something that they need to get used to, and it's something that has lots of constraints on it, legal constraints, for instance, for some data sets. On the application developer side, we need to get used to, as developers, developing for cloud. We have extensible, we have elastic services, but I haven't yet seen the killer app, which is really the killer app for cloud applications. How do you take advantage of the dynamic nature of cloud? How do you take advantage of the elasticity and do all these things at the same time and do something really, really cool? So I think as developers, we need some time to get along with that and figure out how we're going to use cloud to do that. And also in our own stuff, we've been using cloud also for our development processes. So it changes a lot of the way we work from day to day by using cloud to help us develop our own software, but other people developing theirs as well. And then for data centers, the important thing for being able to use cloud in the longer term is getting data centers first using cloud on their own resources. They want to do that. Obviously, they have an investment already. They want to reuse that investment to have cloud resources available to their users in their center. But also, it's very important to train the system administrators themselves. They're not used to cloud-type infrastructure and managing cloud-type infrastructures. So if they're running their own, they need to get used to how do you manage a cloud service, how do you manage users on that type of thing. But more importantly, in the longer term, if they're really going to jump to a model where they're actually managing things on a public cloud, they become less system managers and more service managers. And those aren't necessarily the same skill sets. So in fact, you need to do that migration as well on the human side. So it's a very important transition in terms of knowledge on doing all that as well. And the last thing is just a stated at the bottom is that we go for elasticity is the big thing everyone talks about with cloud. But in fact, there's lots of other benefits with cloud that you don't need big scale elasticity for. And a lot of these smaller and medium sites can take advantage of the dynamic nature, the dynamic way of provisioning resources. And the decoupling between the hardware and the actual services themselves actually makes things a lot easier on the site level to actually do some of these things. And all of that you can take advantage of without having a 10,000 center site. You can do this on a small scale. So that's sort of the philosophy of where we come from and what we've been trying to do. Where did we come from? Actually, we started the group of partners which were involved in doing this. Actually started as an informal collaboration back in 2007. Because when Amazon first got hot, we decided we were all involved in grid technology at the time. We wanted to see how we could use cloud to do grid services. So that's how the collaboration sort of got formed. And from that, we basically identified there was a need for, at that time, an open source cloud distribution, which didn't exist. And that was the impetus for actually a European funded project. So StratusLab was a European funded project. It ran for 2 years. It had six partners in 5 different countries. And basically at the end of the 2 years, which was just this last May, we really do have a production quality distribution that is installed both with academic and commercial centers. So that I think is a really good outcome of that project. And now we're sort of doing in the post-project phase and actually trying to turn this into more of a community-based effort. So what we're doing is an open collaboration now. We're welcome to have individual developers or institutes come along and help us out. All the contact stuff is there at the bottom, and we'll get to that at the end. The reason for this talk basically is to show a bit about what StratusLab is. It's also hopefully to interest either users, system administrators, or developers to come along and actually work with us. So that's the idea here. So the rest of the talk is basically looking at the individual services we have, describing a bit what the implementations are, hopefully interest you as developers. And then if any of you are interested in either running it or using it, then hopefully you're interested as well. The StratusLab services, it's an EBS service. So this is the same diagram we'll see everywhere. It has the same basic blocks. It has compute, network, storage. The thing which is a bit different for us, and links to some of the other talks we've seen today, is we actually do have a set of services to manage images. And that's actually a service which is federated from day one, basically. And that's something which is unusual for a cloud in general, but our implementation of it, I think, has a nice twist to it as well. So I'm going to be spending a bit more time on that later in the presentation on exactly how that works. So we have done releases. We used agile software development practices throughout the project. We actually had about 12 different releases over the course of the project. From our 0.1, basically, it was stable enough for people to use. So we've had users basically from the first 3 months of the project. And since then, it's continued. I just put up the post-project releases that we've had just to show that we are still active and still doing things. The first one after the project was our 2.1 release. It was basically taking the code that had gotten a bit of corrupt from actually being in a European project and all that, cleaned it up as much as possible, and really tried to make sure that we could push this out as a coherent release. 2.1 came out shortly afterwards. We fixed a few bugs that were quite important on the storage side and improved the Windows support. That's something which is problematic for us. So if there are Windows developers out there, it's great to have you come along because all the core developers actually use Mac or Linux. So we actually have very little testing, personal testing on Windows and how that works. And then the release which just came out, in fact, last week, was 13.02. It has support for cloud contextualization and a whole slew of bug fixes that came along with that as well. You notice also we've sort of gone to the Ubuntu type of numbering system rather than the 1, 2, whatever, which ties into our release policy now, which is we're having quarterly timed releases. So we're planning 4 major releases a year, basically, with intermediate bug fixes as needed. So if we really do need to fix bugs in a short time scale, we'll make intermediate releases for that. We do want to provide a sort of a 6-month roadmap, and this talk sort of goes in that direction. We don't have one on the website, which is really just a roadmap with details on what's going to be in each version. So then just going through the services themselves and some of the features. we wanted to put in our implementations. On the compute side, the things which are most important for us were really fast provisioning and really low latency startup of machines. So we really want to have people be able to come along, say I need a new virtual machine, and really be able to SSH into it in maximum 30 seconds later. So we really want to be able to have a very, very fast turnaround on the virtual machine provisioning. The other thing which was really important for us and still is very important for us is we want our users not to be bogged down by having to make their own images. We want to be able to provide them with a set of images that they can use out of the box and just use that as a basis for starting all of their stuff. So we actually do provide a whole set of these. You see them at the bottom. The other thing, it's hard to put contextualization in the compute side or in the image handling side, but we do think contextualization is very important and something that does need to be standardized a little bit better than it is now. We use the OpenNebula, and Hepix is another group which does define something which is very similar for contextualization. Those are both there by default. They're still there. What we've just put in this last release is actually cloud-native support for contextualization. And that is probably the direction we'll be going more toward in the future, making sure that that's rock solid and really works for us very well. So far, we're very impressed with it. It looks quite nice. In fact, it makes our booting of the images and access to the images much faster. On the implementation side for this, the APIs and XMR RPC interface from OpenNebula. So we do currently use OpenNebula at the core of the virtual machine management part. It's written in C++, Ruby, and Bash, sort of a mix of those things, with a lot of customized hooks for our stuff. So basically it hooks in with our storage, our way of doing networking and all of that, and user authentication. The other thing which is really important, it has hooks into our storage, and we actually use our own storage service for a lot of the caching. So a lot of the snapshotting and all that to make the low latency startup possible happens because of these hooks there. And then the images that we provide, we try to provide minimal images for things which are quite common. So we have CentOS, Ubuntu, OpenSUSE, Debian, Fedora, Scientific Linux. I think someone actually put up a Gentoo. We don't support that one, but someone put up a Gentoo recently as well. And there's lots of customized images in our repository. On the storage side, our abstraction for storage is basically disk, so we do volumes. So it's the equivalent of the Amazon EBS-like block store. We provide users, it's not just a block store for us internally, although we use it for that, it's really for our users. We really want our users to be able to have access to storage, persistent storage, so they can store their own data on the cloud and use it from the virtual machines which are there. Something that's extremely important, especially where I come from in sort of an academic, scientific environment. Data is king. Data is the thing which has to be done right for that. So as I said, it serves as a cache of our own VM images. The last thing is comments, sort of a negative comment, if you like. We don't actually have a file-based or object-based storage service. It's not something we felt was terribly necessary. We didn't want to develop it. But this is one place where we actually have a deployment of Neon from another group. They wanted file-based and object-based storage, so they actually use Swift. So they use Swift in addition to our own storage services. So it's very easy to add other things to it if you really need to. The implementation here, it has a proprietary REST interface with all the CRUD actions. It's a REST-based API. It's Java. We use MySQL as a database behind. A lot of that details is probably going to change in the very near future. Behind the scenes, we actually have a set of plugins where you can actually use different types of storage. We use, by default, Momentize SCSI. You can also use a shared file system if you want to use that for your backend storage. We also have yeah.
Excuse me, what do you mean by proprietary REST interface?
So proprietary, it's not standardized in any way. It's one we came up with. It's one that we support, but it's not CDMI or one of the other standards which are out there for. So yeah, proprietary is there.
You'd like to say customized.
What's that?
You would prefer to use the word customized instead of proprietary.
Proprietary, customized, more or less the same. So yeah. So anyway, it's our own API at this moment. We'll get to that later at the end. We also have a plugin, so we use iSCSI and shared file systems. We can also use NetApp as well, so we have a plugin for NetApp, so if you have more high-end hardware, you can actually use that as well. And on the other side, we use simple file volumes for the actual disk and storage images. On the network side, this is something where we've done something extremely simple. Basically means we didn't do much at all, almost by intention. We had three use cases in mind that we really needed support coming from a scientific aspect. One is that we needed users to be able to deploy services themselves, so we needed public IPs for nodes. We needed them to be able to deploy batch systems where you really only need network interconnectivity between nodes within the cloud itself. And the third one is point-like workers, where you have a worker which just does work and contacts some external server every so often to feedback work or get new work, where you don't really need any connectivity at all except outbound IP connectivity. So those are the three use cases we actually support with our networking. The other thing which was really important, which seems sort of counterintuitive, is we don't want to require dynamic configuration of network switches. There are many universities and many groups which run computing that actually don't have access to their own switches. So any kind of dynamic requirement for network switching means they won't be able to use the software. So in fact, that's something we didn't want to put into this. And we don't want to use standard services. So basically underneath we want to use DHCP and the other things that system administrators are already used to using on their sites. So that's sort of the features and inputs for what we want to do with the network. So in fact, it's very simple. There's no API at all. There's no service there. It's really a manual static configuration of the network itself. What we do recommend is basically two VLANs, which are configured, one for the server side of things and one for the VM side of things, just to isolate the two. But that can all be done essentially statically when we deploy things. All the classes of the IP addresses, so public, private, and local, are all optional. So you can either deploy them or not deploy them as you would like. And we really do use DHCP for the VM and initialization and also the machines themselves, so that you basically can store all the information within your DHCP, which most people do anyway. And it's just an easy way to get all the networking configuration done correctly. The downside of this is that the users, people deploying virtual machines, really are responsible for their own security in terms of the network. They're free to run their own firewall, and they should run their own firewall, but they do have to be aware that they're running basically in a virtual network. So that's the downside of having such a simple networking configuration. So then the part which is probably most interesting is the marketplace and image handling. The priorities here are really being able to share and trust images. So we really want users to be able to upload their own images, but we want them to be able to say, I want to share this with other people in my group, or I want to share this with the world. So it's really, how can you upload that and really share that between different people? What we do is we have the idea of a marketplace. The marketplace is really a registry for image information. And we have storage for the contents of those images, which can actually be any public web server. It doesn't have to be in cloud storage, although it can be. The idea is we want to create different roles. So there's a creator role, a user role, an administrator, and validator. All those have different roles within the image handling workflow itself. I'll say just a little bit on the implementation itself, and then we'll go to what the actual workflow looks like. I'll describe it in a bit more detail. The marketplace, again, is a proprietary, it's our REST API. For creating, reading, search, it acts as a registry. It only handles the metadata. The image contents can be anywhere, and private images can actually be put in cloud storage itself. So those are the ideas. The ideas for the image handling workflow. So the image creator, what they have to do is basically create their image. They upload it somewhere where it's publicly accessible. And then they create a metadata registry of what that is and upload it into the marketplace. From there, it's visible to users. Users can actually search the marketplace, find out something that's interesting to them. They just have to know the identifier of that image. And then when they want to run it, they say Stratus run instance with the identifier of the image. And the cloud and everything else takes care of making sure it gets transported to the cloud, cached on the cloud, and used on the cloud. The nice thing is that it's completely transparent to the users, and it's completely federated. So if you have two clouds, they can share the marketplace, and they can actually share images between the two cloud implementations. The other thing, which a lot of things aren't services inside of StratusLab, a lot of things are what I would call tools. To make things easier for either the users or the system administrators, I'm just going to go through these very fast. Basically, the CLI, there's an administrator one as well as a user one to handle various parts of the administration. Then we do things like quarantining stop virtual machines so that you can actually do an analysis of them if you would need to later. There's authentication and authorization, which touches essentially all the services in a common way. It's extensible, and we really want to make that as flexible as possible for particular sites. The other thing which I sort of consider the tools part is really we do go to a lot of extent to try to get as much documentation on our website as possible. We're trying to keep it up to date as much as possible as well. We do give live tutorials usually 2 or 3 times a year, and we have workshops. The next one is in March. You're invited if you want to participate. We have a bunch of StratusLab deployments. So the reference cloud services, we have 2, one in GRNet and one at Lao where I work. Basically, they're open infrastructures, and if you want to become a user, it's basically you just register. It's on the website where you can register, and you can use either one of those infrastructures just to try out and see what it does. The important thing is first come, first served, best effort basis. Even though we're going to have more hardware at Lao very soon, we're essentially 100% full almost all the time. So people are really using it. There are other deployments. We have academic and commercial deployments as well. So commercial deployments, there's one at Atos. There's one based used in Helix Nebula, which is another big European public-private partnership for cloud. And we have people who are actually building stuff on top. So Slipstream, 6 Squared, we've built essentially a deployment and testing orchestrator sitting on top of StratusLab and other clouds as well. And we're starting to get things like someone in my lab actually he loves Go. So he actually made a Go interface to StratusLab. So we're starting to get other people involved in actually building stuff on top. In the last 3 minutes, I guess, of the talk, I'm just going to go through the priorities for the evolution of things. There's sort of 3 big areas. There's interface, simplicity, scalability, and robustness. So these are basically ways to make the services themselves better. And then better services for system administrators themselves. And the 3 marked in red are sort of big changes and the ones I'm going to say a little bit more about. First part is direct use of libvirt. So right now we're using OpenNebula. We're basically using it as an interface to libvirt. So in fact, we're going to simplify things a lot. We're going to remove OpenNebula and actually start talking directly to libvirt itself. So this is a good thing for us. It will simplify exactly what we do. A lot of the hooks that we already use will actually become real components that talk directly to libvirt rather than going through an intermediary like that. So the plan is here. What we can do basically is get rid of OpenNebula and talk to libvirt. The other thing which we couldn't do a couple of years ago because these things didn't really exist in a stable form, but it's really to start looking at using a distributed database as our sort of our message bus and way of tying all of our services together and get scalability out of that. So the plan is really to evaluate that first. We're probably looking at Couchbase and Cassandra to do that. We want to implement a prototype of that and then actually move those databases when they can. And then the last thing is really what we want to do is really implement SIMI. So that's the interface that we've rather decided for us. So that's what we're planning on implementing for our native API. Just as an aside, we do actually have a plugin for Rocky, so if anyone really wants to use OpenCI, we do have an interface for that. So the last thing is really just conclusions. So the StratusLab cloud distribution is there. It's been there for quite some time. It's supported. There are both academic and commercial deployments of this, which are in heavy use at the moment. On the collaboration side, we really do want to be collaborators, both developers and users and documenters if everyone wants to document everything. We have weekly phone conferences between the developers, so if people are welcome to join that if they want to help on the development side. And we have basically workshops every 6 months. People are also welcome to come and do that. Well, things, try it out, give feedback on parts of StratusLab you like or this Yeah, so the last bit, questions and discussion. Are there any questions? Yeah.
What do you think of Turnkey Linux?
So,
Turnkey Linux?
Which Linux?
It's a website junkindex.org, where you have a lot of images ready to use for deployment to the cloud. When you talk about your image marketplace,
Yeah.
it makes me think of that, and they have a lot of methods to build images and so on.
Yeah, actually, I don't know the in detail, but in fact, actually, the images can sit anywhere. Essentially, all you have to do is create the description and upload the description and the URL, and it will work with us. So having a boundary or whatever for images is a great thing. Other questions? Yeah.
Do you have any plans regarding deployment on for networking, like for internet or?
Yeah, so the question was, do we have any plans to take more advantage of networking tools? Yes, probably not in the short term, but in the medium, longer term, yes.
Do you plan to extend legal for that or?
No, we're not networking experts. We hope that something shows up that we can use basically for the networking side. All right, thank you.